So this is a review for the Algebra 1A semester exam. This video is on Unit 1, Topic 1, which consists of problems 1 through 9. I want to remind you that when you take this exam, you will be given this formula sheet. So everything that's given to you in this review on the formula sheet will also be given to you on the exam. So don't spend your time memorizing these formulas, but make sure that you understand them, because your teacher will not be able to tell you what they mean or anything about them. Note also that a calculator is permitted on the Algebra 1 semester exam. So please make sure to bring your calculator when you take your exam. So Unit 1, Topic 1 begins with problem number 1, where it says, Jack wants to put a fence around his property. He knows that the perimeter of the fence is given by the formula P equals 2L plus 2W. Solve this formula for W. So this is solving a literal equation. So I'm going to start with my formula, P equals 2L plus 2W. Now my goal here is to solve for W, so I need to get rid of everything else attached to it first. So when we solve equations, we do PEMDAS backwards, which means we do the addition and subtraction first, meaning we have to get rid of this 2L that's being added to 2W. And then we do the multiplication and division, which means we get rid of the 2 that's being multiplied to 2W. So the first thing I'm going to do is I'm going to subtract 2L on both sides. Now, because I have P minus 2L, and these are not like terms, I can't actually combine them. So my answer is going to be P minus 2L, and it's okay to leave it like that. These cancel out, and we'll have 2W on this side. Now I'm going to get rid of the 2 that's attached to the 2W. It's attached through multiplication. So in order to get rid of multiplication, we divide. So I'm going to divide by 2 on this side, and what I do on one side, I do on the other. These are going to cancel out, and I'm left with W equals P minus 2L divided by 2. I can also write this and actually divide it out and have P divided by 2 minus L, or I can have 1/2 P minus L. You could also write this as 1/2 of P minus 2L, but I don't think any of you would actually write that, because this answer works, or you have your simplified answer. I don't think any of you would actually go to this parentheses and taking out the 1/2. Personally, I would not, so I don't think you should either. Moving on to question number 2. Gino knows the formula for converting degrees Celsius, C, to degrees Fahrenheit, F, is F equals 9/5 C plus 32. He doesn't know the formula for converting degrees Fahrenheit to degrees Celsius. Which of the following is correctly solved for C? So again, this is a literal equation. So I'm going to write out F equals 9/5 C plus 32, and I'm going to do PEMDAS backwards. It's also called SADMAP. If you need to memorize that, it's just PEMDAS backwards. So the first thing I'm going to do is get rid of my addition and subtraction, which is my 32 that's being added. So I'm going to subtract 32, and what I do on one side, I need to do on the other. And because F and 32 are not like terms, I'm going to leave it at F minus 32, which equals 9/5 C. Now, I've got 9/5 times C left on this side, and I'm trying to get C by itself. So I can do this a bunch of different ways. One way is I could divide both sides by 9/5. I don't recommend that because I know that you guys don't like fractions. So another way is I could, and I'm going to put this over here, we have F minus 32 equals 9/5 C, and we have f minus 32 equals 9/5 c. I've just rewritten the problem because I'm going to show you two different ways to do this. The first way is to get rid of the 9/5 by multiplying by the reciprocal, or the multiplicative inverse. So I'm going to multiply both sides by 5/9. But I have to remember that I'm going to multiply this whole side by 5/9, which is why I put parentheses. This becomes 5/9 f minus 5/9 times 32. And on this side, we have c. Now I have 5/9 f, and you can use your calculator. And in your calculator, you press 5/9 in parentheses times 32. That will give you your correct answer. So let me write that. 5/9 in your calculator times 32. It's going to give you this number, 17.77777777. But if you press math, and then the first one, number 1, says frac, you're then going to see in your calculator answer and then an arrow to frac. Press enter, and what you're going to see is 160 over 9. So 5/9 times 32 is 160 divided by 9, which equals c. On the other side, the other way, and this is the way I prefer because then I don't have to worry about fractions, is I see that I have this division by 5. So I'm going to get rid of that division by 5 first and multiply both sides by 5. So what I have is 5f minus, and 5 times 32 is 160, and we're left with 9c because this is going to cancel out with this. Now that I have 9 times c, I'm going to get rid of that by dividing both sides by 9. And what we see is we have c, because these cancel out, equals 5f minus 160 all over 9. What's nice about this version, the way I did it, is that it's already in the answers in the format we want it. So we can see that our correct answer is A. However, looking at this, you can just see that they're both over 9, so we can easily put this into this form by just adding the fractions together. And so that's two ways to do number 2. For items 3 through 5, solve each equation. If there's one solution, give that solution. Otherwise, state whether the equation is always true or never true. So let's quickly review. Always true is going to be when you get a true statement. 5 equals 5, x equals x, 10 equals 10, -2 equals -2. Never true is when you get a false statement. 5 equals 10, not true. 2 equals 0, not true. One solution is when you get a value equal to x, like x equals 2, x equals -10, x equals 0. So we're going to solve each one of these equations, and we're going to figure out if there's one solution or if it's always true or never true. So for this first problem, number 3, I see that I have like terms right here, 4x plus 2x, and I have like terms right here, which is 5x plus x. So 4x plus 2x is 6x plus 18 equals 5x plus x, which is 6x plus 18. Now I always like to put all of my x's on one side. So I want to get rid of this 6x on this side. What I do on one side, I do on the other. And what I see is that 6x minus 6x is 0, and I'm left with 18. And 6x minus 6x is 0, and I'm left with 18. So 18 equals 18. This is a true statement. And a true statement means that it's always true. And just for some extra notes, which you never know, you might need to know, always true statements means that there is an infinite number of solutions. Because it doesn't matter what x is, it's always going to work. So 1 works, 2 works, -10 works, 1,000,000 works. We're always going to get 18 equals 18 in the end. For number 4, I see that I have 5 times the parentheses, the quantity of x minus 2. This is going to imply to me to use the distributive property. So I'm going to distribute 5 to the x and 5 to the -2. Well, 5 times x is 5x, and 5 times -2 is -10. And that equals 6x plus 20. Again, I told you I personally like to bring all of my x's to one side, but there's multiple ways to solve this. I'm going to subtract 6x on this side, and what I do on one side, I have to do on the other. Well, 5x minus 6x is -x. I have minus 10 equals, and these cancel out, so it equals 20. Next, I need to get rid of my minus 10, so I'm going to add 10, because the opposite of subtraction is addition. So what I'm left with is -x equals 30. Now this is not an okay answer for me because I need my x to be by itself, so I need to get rid of that negative. So I'm going to divide both sides by -1, and I'm going to get x equals -30. Since I got x to equal one value, this has one solution that works. So the only answer that will work to make this equation true is when x equals -30. All right, finally, for number 5, I have to do the distributive property again. So I'm going to distribute 9 to both terms, and we get 9 times x is 9x, and 9 times -3 is -27, and that equals 9x plus 15. I want to get rid of my x's on this side. Again, that's what I personally choose to do, but there's more than one way to do it. So I'm going to subtract 9x on both sides. 9x minus 9x is 0, so those cancel out. And I'm left with -27. And then 9x minus 9x is 0 again, and I'm left with 15. Well, we can clearly see that this is a false statement. -27 does not equal 15. Because it's false, it is therefore never true. And again, for those extra notes, that means that there's no solution. There's no value of x that will ever make this equation true. So a food truck sells 3 items: hot dogs, sodas, and fries. In order to make a spreadsheet, the food truck owner needs to define some variables. The symbol capital H is the number of hot dogs sold in one day. Capital S is the number of sodas sold in one day. Capital F is the number of orders of fries sold in one day. Capital P sub capital H is the price in dollars charged for one hot dog. Capital P sub capital S is the price in dollars charged for one soda. And capital P sub capital F is the price in dollars charged for one order of fries. I know this was everybody's favorite when we did Elvira, and yes, I'm joking, but you do need to be able to do this. So the first part is write an inequality for the following statement. The number of hot dogs sold in a day was at least 400. Well, what we can see is that H here is the number of hot dogs sold in a day. So we can write capital H, and then we have was at least 400. That means that it was $400 or more. So H is greater than or equal to 400. And there's our inequality. For the next one, what does the inequality S times P sub S greater than or equal to 1,000 mean? So in this one, we've got S, and that's the number of sodas sold in a day. So I can look at this and see that it's number of sodas per day. And that's what capital S is going to be. then I know that I'm multiplying that by P sub S, which is the price for one soda, so price per soda. If we multiply this out, we know that we multiply numerators together when we have fractions, and we multiply denominators together. So sodas are going to cancel out, because what's on top is also on the bottom. This is going to leave us with the price per day. Now remember, this is the price of one soda multiplied by the total number of sodas sold. So this price is actually going to be our total price per day. And the way that we can write this, we know that it's greater than or equal to 1,000. What it means is the total amount of money, and we should specify this is made by selling sodas, was at least, because we can see it's greater than or equal to, so it's going to be $1,000 or more. So was at least $1,000. So when they sold sodas in one day, they made at least $1,000. All right, C, write an expression for the total number of hot dogs, sodas, and orders of fries sold. Well, I know I sold H hot dogs. I know I sold S sodas, and I know I sold F fries. Well, since we want the total, what that really means is I'm going to add them all together. Remember, it says expression, so there should be no equal sign. So H plus S plus F. On a recent day, less than $2,000 was made selling hot dogs and fries. Write an inequality for this statement. Well, we know that we sold, and I'm going to move this down. We know that we sold H hot dogs. But I need to know how much money was made from that. So H hot dogs times the price per hot dog would give me the total number of hot dogs, like the total amount of money sold, the total amount of money made by selling hot dogs. It's kind of like what we saw right here with B. So that was hot dogs, and fries would be the total number of fries times the price of fries. So we want the total of that, which means we're going to add them together. So on a recent day, less than $2,000 was made selling hot dogs and fries. So we know that this is going to be less than $2,000. And there's our inequality for this statement. Finally, we have, on another day, the food truck sold a total of 1,500 items. There were 700 hot dogs sold. The number of sodas sold was 3 times the number of orders of fries. Determine how many orders of fries were sold. So, we first have that the food truck sold a total of 1,500 items. We know that H plus S plus F is our total number of items, and we know that that's going to equal 1,500. Then it says that there were 700 hot dogs sold. So we know that H, total number of hot dogs, is going to equal 700. Finally, the number of sodas sold, so S, was, which is the same as is, which means equals, 3 times the number of fries, number of orders of fries. So S is going to equal 3 times F. We want to determine how many orders of fries were sold. So what we have is H plus S plus F equals 1,500. But we know H equals 700. We know S equals 3F. And we just have our fries for F. And that equals 1,500. Well, I'm going to combine like terms first. And I see that 3F plus F is 700 plus 4F equals 1,500. Next, I'm going to do SAD MEP. I'm going to do PEMDAS backwards. and I'm going to subtract 700 on both sides. This is going to cancel out, and I'm left with 4f equals 1500 minus 700, which is 800. Finally, to get rid of the 4 and get f by itself, division is what gets rid of multiplication. So I'm going to divide both sides by 4, and I get f equals 200. Therefore, 200 orders of fries were sold. And yes, it's very important to write therefore statements when you have any type of word problem. So I would get into the habit of that now. That and units are two really important things to remember. Sherry solved the equation 1/5 of x minus 20 equals 45. For each step, write the name of the property that Sherry used. Go back to your notes and make sure you know all of the properties that were given on property sheets during this unit. So they're showing you the math, and you just have to write the property. So we're starting with this. That was our original equation. And what we can see is that they distributed the 1/5 to both the x and the negative 20. So this first property is going to be the distributive property. You should write out all the words. Don't take any shortcuts and possibly run the risk of getting something wrong. And this one is just the simplified version of that. Next, we see that they were getting rid of the negative 4 by adding 4 on both sides. So this is the addition property of equality. Finally, we have 1/5 x, and we're multiplying both sides by 5 to get rid of that x. So this is going to be the multiplication property of equality. Notice that because these are all equations and not inequalities, they're properties of equality. When we get to inequalities, those would be properties of inequalities. Next, Sherry has also been asked to create a two-step equation with the solution x equals 10. For each step of her answer below, give the property that she used. So she started with x equals 10. That was her starting point, her solution. And what she clearly did was she subtracted 3 on both sides because 10 minus 3 is 7. So what she used was the subtraction property of equality, meaning that if you subtract on one side, you can subtract on the other and it will stay equal. Next, we can see that she took her x minus 3 and multiplied it by 5. And 7 times 5 is 35. So she used the multiplication property of equality. Finally, she has 5x minus 15, which is 5 times x and 5 times negative 3. So her last step was she used the distributive property of equality to get her last answer. All right. The last problem for Unit 1, Topic 1 is question number 9. On certain multiple choice tests, students earn points for correct answers, but lose points for wrong answers. The formula to calculate a student's score on a test is S equals 2C minus W divided by 4. S is the student's score, C is the number of correct answers, and W is the number of wrong answers. Using the formula S equals 2C minus W divided by 4, answer the following questions. So Saul took the test and got 36 items correct, so that's our C, and 12 wrong, that's our W. What was his score? So S equals 2 times 36 minus 12 divided by 4. All I did was plugged in 36 for C and substituted in 12 for W. Well, 2 times 36 is 72, and 12 divided by 4 is 3, and 72 minus 3 is 69. So Saul's score was 69. On the next question, Francois took the test and got a score of 53. So that's our S. She got 29 items correct. That's our C. How many did she get wrong? That's W. Show how you determined your answer. Well, in this formula, S equals 2C minus W over 4. We have a score of 53 equals 2 times 29 correct minus W over 4. So I have 53 equals 2 times 29, which is 58, minus W over 4. The first thing I'm going to do, I'm going to just rewrite this. 58 minus W over 4. First thing I'm going to do is get rid of this 58 because I'm doing PEMDAS backwards. So minus 58 minus 58. 53 minus 58 is negative 5. And what I have is negative W over 4. So now I need to get rid of the times 4. I'm going to do this in 2 steps just to make it easy, but I know a lot of you will see how to do this in 1 step, and that's completely fine. So my next step to get rid of that divided by 4 is I'm going to multiply both sides by 4. And what I see is that I have negative 20, I'm just going to write it up here, equals negative W. But I need to get W by itself. So I'm going to divide by negative 1, and I'm going to get W equals 20. So she got 20 questions correct. Sorry, I'm running out of space. Finally, Darko took the test and got a score of 80. Sorry, that's our S. He got 8 answers wrong. That's our W. How many answers did he get correct? Show how you determined your answer. So we're starting with the formula, yet again, S equals 2C minus W over 4. Note that I'm showing all of my work. This is very important when you take your exam because you want to try to get as much credit as possible. So my S, my score is 80. I've got 2 times C, we don't know what C is, minus my W, which is 8, divided by 4. Well, 80 equals 2C, and then 8 divided by 4 is 2, so minus 2. Again, I'm going to do PEMDAS backwards, so I'm going to get rid of that negative 2 by adding 2 to both sides. I'm going to write my next part up here. 80 plus 2 is 82 equals 2C because these are going to cancel out. Now to get C by itself, I need to get rid of this multiplication by 2. So to do that, I'm going to divide by 2. And 82 divided by 2 is 41, which equals C. So he got 41 questions correct. I also want to remind you that the best way to check your answer to see if it's right is to plug it back in and see if it gives you the answer you want. This is very important when you're doing your exam because you want to get the right answers, and when it comes to solving equations, it's almost a foolproof method. If you check your answer and you got a different answer, it's wrong. You've made a mistake somewhere. So I just want to emphasize, check your answers as much as possible. Show all your work, and you should do fine. at least on this section of the exam. So that ends Unit 1, Topic 1 of the exam review.